All right, so a lot of talk about how do you know which formula to use and how do you know which data you're supposed to use and all that stuff. And so what we want to do is try to look at a problem and determine which chart we're going to use. So we're always looking for the words test the claim, or always looking for the words construct a blank confidence interval. Okay? So those are the words we're always kind of scanning the problem for. So as I scan the problem and I'm looking for those words, where do I find them at? Test the claim, right there. Now I know that whatever comes next is going to tell me we're either going to test the claim for the mean, test the claim for the standard deviation, test the claim for the proportion. It's got to be one of those three. All right? It's either going to be mean, standard deviation, or proportion. How I deal with them depends on what it says. So test the claim that the target content has a, and there it is. There is your critical piece. Okay? It has a standard deviation different than 3.2. All right. So in this case, anytime we have to test the claim on standard deviation, we immediately know we're going to be into the chi-square area. So we would have part A, HO and H1. HO and H1. And our claim is that it's different than 3.2. Right? We're not saying that it's more than 3.2. We're not saying that it's less than 3.2. All we're saying is it ain't 3.2. So sigma is not equal to 3.2. Our HO would be that sigma is equal to 3.2. It's going to be a two-tailed test, yes. Not equal to. In order for it to be a right-tailed test, it's got to be greater than. That would make it be on this side. In order for it to be a left-tailed test, it's got to be less than, so I'd have to put it on this side. In order for it to be both, you got to say not equal to, which means it could be greater than, it could be less than.
So do we do like the regular bell-shaped, or do we do that funky, drunken looking?
You're doing a skewed graph because it's chi-square.
Okay.
So this area here and this area here. Now keep in mind that these two areas are the same area. I mean, they're equal areas. Okay, so this is 0.025 and this one is 0.025. Okay. Now as we go to do this, what's our degrees of freedom? 24, right? So we got to be there.
N minus 1.
And then we're looking for a 0.025 and 24. So we're at 39.364. Is that right? Do we all agree on that? So for one side, we got 39.364.
Does it matter which side?
Yes. It's the right side. On the left side, 12.401. Okay. Now remember on chi-square, where is 0 at? 0 is on the left side, yes? All right. Part C. You guys know the formula? Chi-square equals n minus 1 s squared over chi-square Oh shit, no.
Isn't it the?
No, it's
Yeah, I'm sorry. Yeah, no.
I was gonna say that's what you picked.
Hush. N minus 1s squared over sigma squared. Okay. Are we good? All right.
So when do we use the left and right formula?
That's for confidence intervals.
Okay.
That's for confidence intervals. All right. We need my calculator. Oh, great. Wrong button. All right. So we got to do n minus 1. Now, again, I would encourage you, as you're doing this at home, and you're doing it on the test, I would so encourage you to live on the edge and just type in 24. I know you want to.
It's dangerous. That's against the formula.
I know you want to put in 25 minus 1, but I just have faith in yourself. S squared is 3.7 divided by 3.2 squared. Okay. We straight? All right, so this turned out to be 32.09. So we're going to go ahead and take a screenshot of this, and that way we'll have it for later on. Because it occurs to me that I did not write down the formula for you. D equals chi squared equals 25 minus 1 times 3.7 squared over 3.2 squared equals, at this point we'll go ahead and copy and paste that sucker right here. And it's equal to 32.09. Now, where's 32.09 in the graph? Where's zero's on the far left, right? So 32 is past 12, right? It's past 12. Not quite to 39, though. So 32 is somewhere in this area here. Do we agree? Is it in the shaded area or non-shaded area? Non-shaded area, right? So with it being in the non-shaded area, at this point, we'll go ahead and proceed and say that we would need to fail to reject HO. Now, which of those was my claim, HO or H1? H1 was my claim? Now, if I failed to reject HO, I'm saying that HO is true and H1 is false. What am I doing to the claim? Am I supporting it or not supporting it? And at this point, I would say I'm not supporting it. So just to finish this thought up, part F at a 0.05 level of significance.
Wait, we failed to reject H1, but we agree with H1.
No. If we fail to reject it with the HO, we do not agree with H1. At a 0.05 level of significance, there is not sufficient evidence to support the claim that sigma equals 3.2.
So H1's only correct if it is in the shaded area.
Reject HO.
Okay. Meaning you would reject HO. Okay. So you only reject HO if it's in the shaded area.
Population is undistributed. Okay. Troy's okay.